I'm Stefan Oehme. I lead the performance team at Gradle. And as you've seen in the keynote, we have quite some performance goodness for you this year for Android builds. So this talk is going to be a very opinionated walkthrough of do's and don'ts for Android builds. You might also have noticed there's two other talks tomorrow, one about profiling Gradle builds in general and the other profiling Android builds. You don't have to attend both because they're very, very similar, because indeed there is not that much difference, just the examples that are different. So don't worry if you can't attend one, just attend the other. And this one will not focus on profiling, but really just on recipes that we found to be useful. So we've been working with the Android team for over half a year now. Thank you guys again so much. It was an amazing experience. And we did find a lot of inefficiencies in Gradle and the Android plugin, and I will be talking a little bit about them. But we also found that a lot of builds out there could have been much faster a year ago without the new Android plugin, just by following some simple rules. So those are the ones that I want to focus on now. So yeah, why would I follow the advice in this presentation? Well, I probably don't need to tell you because the Android community is pretty vocal about that slow builds suck. But just if you imagine, the example that I'm going to show takes 30 seconds to make a one-line change and then repackage. So if you think these 30 seconds of waste, you do like 50 builds a day, you have a medium-sized team of 50 developers, that's 21 wasted hours. Or put another way, that's 3 of your developers sitting there the whole day, just twisting thumbs. Like, would you approve of that if you walked into the office and there were 3 guys sitting there like, yeah, I'm important here. You probably wouldn't. So why do you accept that in your build? And that's not even taking into account the cost of lost focus. I mean, that's just the pure waiting time. But what happens if you launch a build and it takes longer than, I don't know, 5 seconds? You go on Twitter or Facebook or watch your favorite cat videos. So the actual cost is much higher than this. And not just that. I mean, anyone who's worked with a slow build knows that it's highly demoralizing to not get fast feedback on the changes you make. And in the long run, you will lose talent if you don't take this problem seriously. People will just go somewhere where they're more productive. So the example that I'm going to show is actually an example application by the Android team. It's called the Center Tracker. It's been around for a while, and it's basically a demo of how a good Android application could look like. It has 9 sub-projects, about 500 Java files, 1,700 XML files, so quite a lot of resources, also quite a lot of PNGs. It doesn't use annotation processors, which by now is kind of special, and I will talk about that as well. And the final APK has a size of about 50 megabytes, so it's a pretty huge app in the end. You can find it on GitHub, my modified version for this talk. And the performance numbers when I started out with this project were like this. Configuration time, so just calling Gradle help takes a full 2 seconds. Just this awkward pause when you say, Gradle, do something, like, okay, here's what I'm going to do. The single line change scenario, so you just take a source file and you change a single method body, not even changing the API of a class. It took 30 seconds until the application was repackaged. And a clean build about 60 seconds. So you know there's something wrong when a single line change only is about half as slow as the clean build. You want that to be way, way faster. So this project has problems, big ones. So when I talk about configuration time, how many of you know exactly what configuration time is? Okay, so let's just quickly go over the build lifecycle. When you run a Gradle build, the first thing that happens is we need to start up. So when you launch on the command line, that means we need to start up the command line client. So that's a small VM that connects to the Gradle daemon and then prints the output to the console. When you're running from Android Studio, that is not the case because Android Studio is already running, and Android Studio is the client. After that, we will look at the build source project. So if you have any code in your build source directory that will be compiled, then your settings.gradle file will be evaluated. And then we go through all the projects and their build scripts and evaluate all of them, apply all the plugins, etc. That's configuration time. And then finally, we figure out which tasks do we need to run in order to fulfill your request and run exactly those tasks. That's execution time. Now, there is some general advice that affects all of those build phases. So let's start with that. First thing you should always do is updating to the latest Gradle version. In every single Gradle version, we put so much work into making performance better. You're really missing out if you stay behind. And also, by staying up to date in between minor releases, you will get deprecation warnings earlier. So we'll see, hey, we're going to remove this thing in the next major. You should stop using it. So it might be somewhere in your code, or it might be in a community plugin. Whatever it is, you can take actions to prepare for the next major release. But if you don't upgrade from minor to minor, then the next major release might surprise you with breakages that you didn't know about. So Gradle 4.0 is a particularly exciting release for Android users because it enables the new Android Gradle plugin 3.0. But it's also great in its own right. So what we did is we have faster dependency resolution, faster configuration time, less memory usage during configuration time, parallel downloads of dependencies and their metadata. So there's lots of goodness in itself when upgrading to Gradle 4.0. But of course, the real deal is upgrading to the new Android Gradle plugin, which is currently in alpha, but I would say it is well worth the look, even though it's not very stable yet. So you can just change your build script log to use the new Google repository and depend on version 3.0. Alpha 4 is the latest, if I'm not mistaken. Did you release something new? No? Good. And this plugin fundamentally changes how an Android project is built. So before, there were some APIs missing, basically, in Gradle. And Adam touched on this quickly in the keynote. Gradle could only build one variant, basically, when you depended on another project. So what the Android plugin had to do is discover all the dependencies at configuration time to figure out what it needs to build, which task it needs to run. So it was a very expensive at configuration time. And then when you had a dependency on a library, it would just always build the release version by default, which probably was very expensive compared to building the debug version. So the cost of adding libraries, splitting your project into smaller modules, which is generally really good advice, was very high. So people generally stayed away from it and had everything in one big app module. And that is just completely changed now. Gradle has introduced variant-aware dependency management, which means the Android plugin can describe, okay, I produce 6 different variants: debug, release, ARM, x86, for this min SDK version, for that min SDK version, whatever. And the downstream project can say, okay, I now want to compile the debug ARM version. Please give me my libraries for that variant. And that fundamentally improves configuration time because nothing needs to be looked up front anymore. Can just do it when it really needs those dependencies. And it doesn't need to build anything that it doesn't need. So in the old version, it would build the full AAR of a library just to merge the manifest of the app. So the manifest merge task would be waiting until the full AAR of a library is built, like the Java classes are built, resources are merged, etc., before anything in the app could start executing. Whereas now, we can actually say, hey, I need the manifests of the debug ARM version, please. And as soon as that is ready in the library, I can start merging the manifests in my app. So this has really improved parallelization as well. So yeah, if you do one thing, give 3.0 a try. Now, let's get into some configuration time advice. So we're using the latest Android version, and all is good. The Android plugin is efficient, Gradle is efficient, but there might still be code in your build scripts or in some community plugins that might be doing things wrong. And let's look at some patterns of what can usually go wrong. So configuration time, just to recap, consists of applying all the plugins that you have for your project, evaluating the build script of the project, and also running any after evaluate blocks. So I've seen some confusions for plugin authors that thought that after evaluate somehow means that it's not run at configuration time. After evaluate totally is part of configuration time. Like all after evaluate blocks will be run for all projects before any task can be executed. It's just a mechanism that allows a plugin to respond to what the user did in the build script. So you apply the plugin, then the rest of the build script is executed so that the user can supply some values to your DSL, and then in an after evaluate block, you can react to those values. So that's all part of configuration time. And configuration time runs when you run any task, even Gradle help, even Gradle tasks. So if you have a 10-second configuration time, and that's not the worst I've seen, that means just to know what tasks I could run, I have to wait 10 seconds. That's the most frustrating thing I could imagine. The same applies to Android Studio Sync. When you click the Sync button in Android Studio, your project needs to be configured to get the latest project model. So every action you do with Gradle will run configuration time. So you want to make this as fast as you can. A good number, by the way, is below 1 second. So and that's for big projects. For small projects, we're talking about 50 milliseconds. Yeah. So the first and most common issue is resolving dependencies at configuration time. Usually accidentally. I've rarely seen it deliberately broken, but it can happen accidentally quite easily. And I've taken a not very Android-specific example because it's much easier to look at. You might have seen such a snippet on Stack Overflow. It's usually the top-voted answer, but it's wrong. So this uberjar task, what does it do? It packages my main output, and it packages my runtime class path as a flat collection of classes by looking, is it a directory? Well, then I just inline it. Is it a jar? Then I explode it. What's wrong here? We're saying from configuration runtime.collect. And Groovy's collect method is eager. So it will actually go and get the files for that configuration and collect them. So that means this piece of code runs at configuration time and resolves all those dependencies every time, even if you don't run the uberjar task in the end. So you want to be very careful. Like anytime you calling get files or collect or any kind of those methods will resolve dependencies. Don't do that. Instead, what you can do, and that is true for pretty much all of Gradle's APIs, wherever we accept files or file trees, etc., we will also accept a runnable or a closure, a callable or a closure. So it can say from, and the difference is actually pretty small in this example, and just say a closure that will return this exploded class collection when it's actually needed. Okay. One caveat with that, since we put this into a lazy closure, it's now opaque to Gradle where those files will be coming from, so what the dependencies of those tasks are. So I need to tell it, by the way, this task's inputs now contain the runtime configuration. So that Gradle knows before I can execute that uberjar task, I need to have built any project artifacts that are in the runtime configuration. So you need to make sure that Gradle knows all your inputs, they're not hidden in some lazy collection. Another common beginner mistake, but it happens even to advanced Gradle users from time to time, is just forgetting how to write a custom task. Can anybody say what's wrong with this task? Well, you can say, of course. That's cheating. Go ahead.
All of that stuff's going to happen every config
Exactly. So it's doing its logic, this block, this closure, when I say task, project stats, this closure is the configuration closure for that task. So I'm configuring the task, but what am I doing? I'm actually writing that file. That's not what I wanted to do. I wanted to say this task will write that file when I execute it. So, very common mistake, forgetting do last. Yeah, that's how you write an inline task. So what we've done here is we say, okay, my inputs is the main Java sources, my outputs is that stats file. And then in my do last closure, I'm actually going to write that file. And I find that kind of clumsy, so I really don't like those kinds of inline tasks. So I would always recommend just write a custom task, make it explicit, make this separation of code and data explicit. So here, I just wrote a simple class called project stats. It has an input file collection, the sources, it has an output file, and it has an action. And it's very clear the action will only happen when the task is executed. So that's where all the expensive code is. And then in my project configuration, I'm just saying, create me one of those project stats tasks, please. And the stats file is this one, and the sources are source main Java. That way, there's no danger of making this mistake. So always prefer these kinds of custom task classes. Another problem that I see very often, and this one is very obvious, it's often more hidden, is that a plugin does something expensive, and then it's applied to all subprojects. And then you have 50 subprojects, and it's going to do that expensive thing over and over and over again. And the solution is usually simple. Either you want to somehow cache the result. For instance, you can put it in the root project in a property and just say, here's the result of my calculation. I want to reuse that. Or you just flip the relationship around and you say, I'm not going to iterate over all my subprojects and run that expensive thing. I'm going to run the expensive thing once and then assign the result to my subprojects. And I'm going to fail if someone tries to apply me several times in the same hierarchy to really make it clear, hey, if you do that, I would be way too slow, so just fail. Yeah? So this plugin, for instance, is using Git to tell what the current version number for the project should be. It's quite a typical thing that people do. For instance, get the latest tag or get the revision number to put somewhere in my manifest file or put in my version number. And it does, for each subproject, apply that plugin. And for 100 subprojects, that already adds about a second of configuration time. Whereas if you do it like this, you do it once, apply it to the root project, and then just iterate over the subprojects and just say, set the version to what I just calculated. You do it once, and it's 10 milliseconds. So there's not really anything very Android-specific in terms of configuration time. It's the same mistakes that you can do in any other Gradle build as well. It's resolving dependencies, it's doing file I/O when you really meant to do it at runtime, and it's doing expensive things for each subproject. Now, execution time, we get a lot more Android specific because there's a lot of low-hanging fruit there. So for execution time, what we want to do is we want to execute what the user asked for. And we want to do so in an incremental fashion. Gradle can also parallelize tasks. And since quite recently, can also cache the results. And the one thing that you want to make sure is that you do as little as possible. That's how you make your build fast. Surprise. So what I often see is that builds are doing a lot of work that might make sense on a release build, but doesn't make any sense on a developer build. So you really want to make your developer build the default. So when a developer checks out the project, then he or she will get the fastest, most streamlined experience that you can give them. And then on CI, you do all the heavy lifting to create highly optimized executables for your target environment. But you don't need that on a developer machine. On a developer machine, you want fast turnarounds. So how can you do that in the Android world? There's really two complementary concepts. Most of the things in the Android plugin can be configured through Flavours. So for this exercise, we're going to create two flavors of our application. One is production and the other is development. So we're going to have a development flavor, and our developers will select that one in Android Studio and will always work with this development flavor, or at least most of the time, unless they specifically need to address an issue that only shows up in a specific locale or some other specific production issue. There are some things that you can configure via Flavours, although I just talked to the Android team and they definitely plan to make everything configurable on Flavours. But still, also for general Gradle projects, I just want to give you this second tip, which is it's very easy usually to detect that you're running on a CI server. Like all major CI servers put some environment variable somewhere, like the Travis job ID or the Team City build ID, etc. So you'll always be able to tell, oh yeah, I'm running on my build server. So the inverse means I'm probably running on a developer machine. So you can just define a property and say, hey, am I running a CI build? And you could even make it configurable that the user can say, okay, actually I want to pretend I'm on CI because I'm seeing a problem that's really obscure and that only shows up on CI, so I can pass -p, pretend I'm on CI. Yeah. But the development flavor should be the default. So the first and really major performance gain is when you're using multidecks, use native multidecks for development, which requires min-SDK version 21. If you use anything lower than that, you're going to get legacy multidecks because older SDK versions didn't support multidecks natively. And that requires a very expensive merging step. So of those 30 seconds that I showed earlier, roughly 20 were just dexing. And you can avoid all that just by using native multidecks. And Android Studio in the latest versions will actually try and enforce that when you're connected to a device that uses this more modern SDK. So it will basically do the work of configuring this for you. But when you're running from the command line a lot, don't know how many of you do that, then configuring it explicitly can also help. Same goes for splits. This is also something that for developers, you probably don't need it. Splits allow you to build highly optimized APKs for just one target architecture, for instance. So leaving out all the resources and native binary files that you don't need on that architecture. But for a development build, you don't care. You don't care how big your APK is. You just want it to be built as fast as possible. So for a developer build, you can probably disable this. Same goes for PNG crunching. Your users definitely care how big your APK is, so you want to compress those PNGs as much as possible. But your developers, no, they don't want to spend time crunching PNGs. They just want to redeploy the app as fast as possible. So same here, just deactivate it on developer builds. The same goes for resources. When you're developing and making incremental changes to the behavior, you're probably not going to switch languages all the time or switch resolutions all the time. You're probably going to work on the same settings the whole time, trying to make some behavior better. So by including the minimal amount of resources, just English and extra HDPI, for instance, can save you a lot of time merging resources. So you see that all of these tips are about not doing things that are not going to improve the experience of the developer. It's just going to add time to the build. Another thing that, sadly comes up again and again in almost every build I've seen, actually, there's one of those. A plugin or a build script that assigns some unique ID somewhere. So for instance, what I see a lot is people putting a timestamp into their jar manifest. Because, I don't know, that's what they've always done. I don't see a good reason why you would need that information, especially not on the developer build, maybe on a release build. But you might want to question if you even need it on a release build. But there's also plugins that generate unique IDs. For instance, Crashlytics, by default, will insert a unique ID into your manifest. And that ID is there to correlate whatever the user is running with when it was built. So you know, oh yeah, that was commit number whatever. We should look back and see why that failed, or if we've already fixed that, if we already have a ticket for that in our issue tracker. But do you want that on a developer build? No. I mean, if it crashes, you know why. The problem is local. So just deactivate it. Yeah. And also look at tasks that are out of date every time. So if you run an assemble debug, for instance, and you make no change and you just run it again, and you see more than 0 tasks running, then there's something wrong. There's either a task with a timestamp somewhere in it, or there's a task that's just not, that doesn't define any outputs and will always run. There might be a task that's just not correctly reporting that it did nothing. So some tasks have some custom logic to determine if they're going to actually do something, or if they're basically up to date, beyond Gradle's normal up-to-date checking. So for instance, incremental Java compile is one of those examples. There's the up-to-date check that looks, did any of the sources change? And then there's the incremental compile check that runs inside the task. And if that turns up to say, oh, actually, there's nothing affected by this change, then the task says, I didn't do any actual work. So on an increment, on a build, on a no-op build, you want to see 0 tasks running. That's the ideal you should always strive for. And that way you will find those pretty easily, because they will stick out like a sore thumb. They will run every time. And from Android Studio, there's a really cool feature that avoids a lot of work, and that's Instant Run. Probably all know it, but just another reminder, use it. It's really cool, because what it means is we're saving all that time packaging the application every time and pushing it over our USB connection to the device again. Instead, we're just compiling classes and pushing whatever changed there. So again, in that example application, it shaved off another 2 or 3 seconds on every build just packaging up that whole APK. And that is an incremental packaging. Now, there's a topic that I will only scratch the surface of here, and that is incremental Java compilation and compile avoidance. The short story is, with the Android plugin 3.0, you get those features for free. They're active by default. All you need to do is, for incremental compile to work, not use annotation processors. I know, it's sad. But we'll get to it, I promise. So compile avoidance is all about looking at the class path and seeing, oh, well, actually, none of the ABI changed. The compiler doesn't care about method bodies on the class path. It just cares about the signatures. So what Gradle will do is it'll just hash the signatures. And if those didn't change, then all the rest doesn't matter. So if you added something in your library project, and you just added a method body, then your app doesn't need to recompile at all. And incremental compile is when there is a signature change, or there is a change in your app, then we only recompile the classes that are affected by that change, so that we're somehow using that class in some form. Unfortunately, until now, annotation processors kind of ruined that game, because they can basically access anything they want, and they can generate new types that would need to be cleaned up later. So we will need some collaboration from them to make them work incrementally. And we'll get there. There's also, and the plugin 3.0 will be very vocal about this, a new API implementation separation. So up until now, you're probably used to defining your dependencies as compile or runtime. And the Android plugin will now tell you, hey, stop doing that. Use API or implementation, please. And the reason is, we don't want to recompile downstream modules if just some implementation dependency changed. We don't want to leak our implementation dependencies onto the compile class path of downstream modules. if I'm using, for instance, Guava internally in my method bodies, but I have nowhere on my signatures, then downstream projects shouldn't need to compile against Guava. And of course, the same is true for intra-project dependencies. If I have a bunch of helpful libraries, then I should make a clear distinction between this library is part of my API. If you compile against me, you're also compiling against that library, versus this library is just an implementation detail. You shouldn't worry about it. And so that way, we can cut the snowball effect of changes very short. As soon as we hit an implementation dependency, we no longer need to compile anything that's downstream from that. It's not going to leak anymore. There's a whole talk on this topic, so I'm just going to refer to that. Tomorrow, the last slot, Cedric Champeau will talk about maximizing incrementality. And of course, to benefit from that in the best way you want to break down your app into more modules. And I'm going to emphasize that a few times more. You want to have small modules so that even tasks that are not incremental can still be fast because they're only building a small set of inputs. So this is especially important, for instance, when you're using annotation processors right now, because they're not incremental. So you don't want to have a 5,000 source file source set rebuild on every single line change. You want to break that down into a few libraries so that you're only changing, maybe recompiling 100 source files at a time. Yes, and as I mentioned, annotation processors are currently the highest voted issue in our issue tracker. So we hear you, and the Google team and other partners are working together with us to make this happen. So we will provide an API for annotation processor authors to participate in incremental builds, incremental Java compile. And we'll let you know on GitHub as soon as there is something to try out. All right, let's talk about another reason to break down your app, even if we had incremental annotation processors, and that's parallelism. So here you see the center tracker application, which has 10 subprojects in total, or 9 minus the root project. And we're executing serially, and it took about 33 seconds. Wouldn't it be much better if we did some of that work in parallel and actually used all those CPUs in that machine? So that's what you can do with the -- parallel option. You can tell Gradle, hey, my projects are decoupled from each other, so you can run their tasks in parallel. And that, in this case, cuts the build down to 20 seconds, which is a pretty significant saving. Now, what does decoupled mean? It means that the tasks, when run in parallel, must not influence each other. So for instance, if they're using some shared database and deleting each other's entries because you're running some integration tests, that would be bad. That would be coupled tests. So you can't use parallel in that case. So you should always strive for making your tests or your tasks in general as decoupled as possible so you can benefit from -- parallel. Now, you already heard it this morning in the keynote. We designed a new API to basically deprecate this very crude instrument, because it's really just saying, hey, Gradle, trust me, my projects are decoupled. And it's very easy to say trust me, but then actually mess it up. So instead, we're providing an API for tasks to run work in a safe, isolated environment where we know it's not going to interfere with each other, and it's going to be on a task-by-task basis. So if one out of your 500 tasks in your project is not parallelizable, it doesn't completely return you to serial mode. Instead, you just don't run that one thing in parallel, but all the others. So that's going to lead us to a parallel by default mode in the end. So by the end of this year, you can expect Gradle to utilize your CPUs really well out of the box. In the meantime, you can also do this on a more granular level. For a single test task, you can tell Gradle, hey, this is a pretty big test task. This has thousands of tests or some very long-running tests. Please run them in a few different processes at the same time. Split them over 4 processors, for instance. So that way, you can at least benefit from some parallelism when executing the most costly thing in your project, probably the tests. Now, this is one of my favorite topics because there's so much false information on the internet, like, yeah, if you have an Android project, it doesn't matter how small, you need 6 gigs of RAM. Like, who's read something like that? The claims are crazy. It's not true, okay? Gradle and the Android plugin, especially in 3.0, are very efficient about memory, actually. So you want to provide enough memory for the size of your project. And for most projects, the default of like 1 gig is plenty. And you don't want to go overboard. Like, even if your project is really big, let's say you have 100 or 200 sub-projects and a lot going on in your project, then yes, you might need 2 gigs. But don't go straight to 8. That's not going to make your build faster. It's actually going to make it slower. Because every time you have a major garbage collection, the longer your heap is, the bigger your heap is, the longer it's going to take for the JVM to walk over it and collect all those references. So you're just making your garbage collection pauses longer by giving it a huge heap. So just do some experimentation and find the size that works well for your project. The Center Tracker app works perfectly fine with like 500 megabytes of RAM. So even below Gradle's default. You can, when you have like big processes, like you have one single compile that compiles 10,000 source files or 100,000 source files, then this might dominate your whole garbage collection profile and might actually ruin an otherwise a very small footprint build. And in that case, you can use forking. So we have a compiler daemon infrastructure. So it's actually efficient. The compiler daemon will keep living and will be warmed up, so subsequent compiles can run on the same compiler daemon. And that will basically put the memory pressure into this daemon, where it only affects the compilation, but not every other task that's running in your Gradle daemon. And the same goes for decks, which with the Android Gradle plugin 3.0 final, so not yet, but soon, will also move into its own daemon, because it's a really expensive process, very memory heavy, and you really want to have that. You don't want to have that running in the main Gradle daemon, slowing everything else down. You want to isolate it. So yeah, don't believe the FUD on the internet. 1 gig of RAM is plenty for almost every project. Now, last but not least, you've heard about it again in the keynote. Caching will come to the Android Gradle plugin, and it already yields some pretty nice results, about a 50% saving on the clean build for a very large app that we tried with 100 submodules. And it will only get better until the final release. So you can start experimenting with it, just turning the local cache on, for instance, and seeing how it affects your builds. It especially helps on branch switches, because before, when you switched from one branch to another, Gradle would just say, well, there's a bunch of tasks that are out of date now. Maybe the branch even had a different Gradle version, so we needed to rerun everything. Whereas now, with the local cache, the results from when you left that branch will still be there in the cache. So when you come back, you worked on a feature branch, you come back to master, and you run your build, it's all still there in the cache, so it will all be very fast. All right, let's see some results. So after applying all these best practices, except caching, that would have been too unfair versus the old Android version. So by applying all these best practices, these are the results that I got on the Center Tracker app. Configuration time is already pretty nice. So it's about 500 milliseconds over there, 2 seconds over there, and we can still go lower. The single line change is my favorite. So on the right side, you have the fixed version, and it takes 4 seconds. On the left-hand side, we're going to have to wait a while, because that's going to take about 30 seconds. Initially, when I designed these slides, I actually put the right one on a loop. It was quite fun to watch, but then it kind of also looked like it wasn't finishing. So yeah, this was your old developer experience before you followed those tips. Every single time. It's finally done. Yay. and the clean build. I hope we have the time. So that's not as drastic, but still, we're saving about 25% even on the clean build by doing this. And with the cache, the clean build scenario would be, well, for this example project, almost negligibly slower than the incremental one. And there we go. 22 seconds, which is actually 50% saving. Even better. Oh, here, in that case, I actually left it in on loop. So we're going to see this build on the right complete a second time before the old one completes one time. All right, I'll spare you the pain. So if you're having deeper issues, you've applied all those best practices, and your build is still not fast enough, then there's several ways, and I will present them in the talks tomorrow. So pick either one. There's getting insights with build scans, so seeing what's taking long in my build in a high-level overview, really richly presented for you in a way that you can easily digest and see, oh yeah, of course this piece of configuration logic is the problem. And you can use the Gradle Profiler, especially if you need to go down to the method level. You've written the plugin and you just can't figure out why it's so slow. Then you might want to go down to the method level and profile with JProfiler or YourKit what's going on. And that is what you can use the Gradle Profiler for. It allows you to automate your scenario testing. So you can look, hey, please run this build 10 times and then take a snapshot. So that's really useful. Also for getting in touch with us, because we accept snapshots. If you really think that there's a problem with the Android plugin, or if you think there's a problem with Gradle itself, you can send us a profiler snapshot and we will look into it. But please first look if it's in your build scripts or in a community plugin. So we have plenty of resources on performance optimization. We have the Gradle Performance Guide. There's an Android-specific performance guide that the Google team wrote. There's the 3.0 migration guide. And if you're a plugin developer, you really want to look at the plugin development guide. If you're a build master, you want to look at the structuring build logic chapter to learn how to compartmentize your build logic to make it easier to find problems. And you don't need to take photos of this slide. They will be online. So if you want to reach out, for Android, the Google team told me, just ask on Stack Overflow. For Gradle-specific issues, ask on discuss.gradle.org. Found a performance issue in the Android plugin, attach a JProfiler or YourKit snapshot when filing a bug. And the same goes for Gradle. If you want to report a performance bug that you found, just attach a JProfiler or YourKit snapshot to a GitHub issue, or if it's somehow confidential, you can also send it to performance@gradle.com. Just please don't expect us to respond right away, but we will look at it. All right. And that's all I have for today. So if you want to learn how to dig deeper and find issues that are specific to your build, you should come to my talk tomorrow. Thank you very much.